Amazing, guys. So as we mentioned earlier, or actually as I mentioned earlier, AWR report is one report which is very important in terms of understanding what is happening inside your database, right? It is really important. So what we will do is we'll quickly connect to my AWS server and generate one AWR report. Now, to understand AWR report, you need to first understand how does AWR collect the statistics and knows what's happening inside your database. So there are a few indicators when it comes to Oracle performance. Let's take, if you want, I'll give you an example. Let's take for your car, if you want to know how the performance of the car is, it starts with the dashboard. You can see the fuel indicator, you can see the engine heat indicator, you can also see a couple of other things on the dashboard. So the first level of debugging starts by looking at the numbers or some indicators that show you whether something is right or wrong. That same thing goes with Oracle, and that is done by the AWR. What it does is it takes something called as snapshots. Let me actually open Paint. So what happens inside your database, AWR, what it will do is it will take snapshots. What are these snapshots? These snapshots are like your dashboard. So performance dashboard. These snapshots will store some details like what is the database load, and what is your instance status, what are the top wait events. I'll talk about wait events in some time, and then top wait event classes, and then top SQLs, and again much more data. So what these snapshots will do is it will capture the status of your database and stores it in something which we call as snapshots itself. So the next question becomes like, if okay, at what frequency Oracle stores these snapshots? In general, every hour these snapshots are taken. All right, so every hour what Oracle will do is it will take the snapshots and it will keep the data inside the Oracle database, so that when you generate the AWR report, inside the report you can see complete details regarding the database. Now again, the next question is like, let's take if Oracle is generating or capturing these snapshots every hour, then it will become a space issue, right? Because every hour Oracle is taking the snapshots, then definitely it will be an impact on the SysOps table space, because all the performance related matrices, they all reside under the SysOps table space. Of course it does happen, but by default in a normal Oracle database, these snapshots are kept only for last 7 days, and before last 7 days snapshots will be auto deleted. Of course you have a mechanism to increase it in case if your client requires you to store more more number of days for your snapshots, then you can definitely modify an internal parameter which is known as dbms underscore workload underscore repository. This is the package which you need to modify in order to increase, decrease, or modify anything which is related to your snapshot settings. So if you modify those snapshot settings, then what happens is it will impact the way snapshots are being taken inside the database. Now, as a thumb rule, guys, it depends, like from environment to environment. Any performance issue would definitely be reported within 7 days, right? If you generally look at something, or if there is a performance issue that is reported by an application team, if a performance issue being informed by a developer team, then understand this, guys, if now they are facing performance issue, then only they'll report. Correct. Let's take or max to max, they would report you maybe within next 24 to 40 hours. Nobody will say that, hey, 5 days back we had an issue. Of course, there are instances that does happen, but 7 days is a very good time in order to store the snapshots. And I don't think there will be a requirement to store snapshots beyond 7 days. So now these snapshots are something that you need to know before even generating AWR report. All right. So the question is, now these are a couple of important questions that you should know. Okay. Let's take, when we say snapshots are being taken every hour, right? So we assume that 11:10 a.m. one snapshot was taken, then 12:10 p.m. another snapshot was taken, then sorry, then 13:10 p.m. another snapshot was taken, and so on. So we have all these snapshots, but there was a performance issue, or somebody reported a performance issue and said database was slow between 10 a.m. and 2 p.m. and after 2 p.m. everything was normal. Now the question becomes, do we generate these snapshots or do we generate the AWR report starting from 10 a.m. and directly till 2 p.m. All right. So guys, I'll hold exactly right here because I'll come back to this concept. Before I proceed over here, let us first try to generate an AWR report, then you'll be able to relate the concept. So first thing first, sysdba user can generate a AWR report. So SQL plus /sysdba. Now, once you are connected, it is very simple to generate an AWR report. It is dead simple. There is only one script that you need to run. So under your Oracle home, Oracle_home /rdbms admin, this is the location where all the RDBMS scripts provided by Oracle resides. And within this script location, we do have a report called as awrrpt, that is awrrpt.sql. This is the script that will generate the AWR report for you. All right. Now, once you hit enter, as I mentioned earlier, guys, it deals with the snapshots. Okay. And in some time, you will be seeing how or where it asks for the snapshots. So the first part it will ask you is, what type of report do you want to generate? Do you want to generate an HTML report? Because this HTML report will be a GUI report that you can view on any browser, maybe on Google Chrome or maybe Internet Explorer. Then you can generate a text format report that will be shown on your screen. And I'm not a fan of text report because the HTML one seems to be fancy because it has GUI interface and all. So the HTML is default. It will ask you to enter the value for the report type. Even if you don't enter, it will take the default value. So I'm just hitting enter. Now in this one, can you see this will actually give you the details about the current instance for which you are about to generate the AWR report. All right. And then it will ask you specify the number of days of snapshot to choose from. All right. So for how many days in the past do you want to display the snapshots? So let's take, we will say like for past 3 days, right? For the past 3 days, we want to look at all the snapshots that are available inside the database. Now, this is where the actual performance tuning starts. So as you can see, the timing is at every hour automatically Oracle is taking the snapshots, and this is the snap ID, which is very important for you. So I'll come back to it. Okay. Now we are going back to our example where somebody said, hey, the database was slow between 10 a.m. and 2 p.m. So the question over here becomes is, should we generate an AWR report between 1039 and 1043? Can you see 1039 snapshot was taken around 10 a.m. and then 1043 snapshot number was taken at around 2 p.m. So these are like, you have two methods over here. I can generate one AWR report that starts at 1039 snap ID and that ends at 1043 snap ID, because between these two snap IDs there was a performance issue. So performance issues are generally identified by the time. Okay, first you identify the time between which the performance issue happened, and then take the snap IDs and then generate the AWR report between the snap IDs. I'll repeat. All the performance issues, first you need to know the timing, what time the performance issue happened. Now based on that timing, in our example, let's take 10 a.m. to 2 p.m. there was a performance issue. In this case, then what you do is during that time you pick up those snap IDs and then generate an AWR report between those snap IDs. Now the biggest question over here is, do we generate one AWR report or do we generate multiple AWR report? Why? Because from 10 to 11 a.m. we can generate one AWR report, right? From 11 to 12 we can generate another AWR report. From 12 to 13 we can generate another AWR, and then from 13 to 14 we can generate another AWR. What do you think, guys? Which one is better? Should we go for multiple AWR reports or should we go for one AWR report? Anyone can answer this one. What do you think? What are your thoughts?
Multiple.
Oracle recommends that we have to generate AWR report each hours, and if we have a serious issue performance in databases, we have to generate AWR report each 20 minutes.
Correct. Right. So the thing is, like, as per the Oracle's recommendation, what Oracle recommends is you should go for multiple AWR reports so that you get to know in-depth details of what exactly was happening during each hour. Because see, if you go for one AWR report from 10 to 2 p.m., what will happen is you will get averages, like average of all the problems. But when you generate multiple AWR reports, in each specific report, what you can do is you get the real gold over there. Like if there was something that was causing problem for your Oracle database. All right. Now, for our example, like for your example, what I'll do is I'll quickly generate an AWR report between 10, we'll continue 1050 and 1051. Now, one important thing, guys, let's take around 2020, exactly at that point of time you shut down your database. Okay, there was a database bounce. So if you are generating an AWR report between 1049 and 1050, then you will not get any output. This will throw an error saying like your database was down. So what Oracle needs is, it needs a consistent open database. There should not be a shutdown between the snapshots that you are trying to identify the issue. Of course, a production system, you know, like it's very hard for it to be shut down. So generally those kind of problems do not come. But on some development databases, sometimes when you're trying to generate, or a test database, when you're trying to generate an AWR report, if there is a shutdown in between two snapshot intervals, then you won't get the AWR report. Just a thumb rule, but it generally doesn't happen in the production system. So let us pick up some random snapshot IDs like 1063. Let us assume somebody reported like on 19th April, exactly at 10 a.m. there was an issue at around 10:30. So what we'll do is it will ask you, your report will ask you, enter the value for begin snap ID. So 1063 is our begin snap ID, hit enter. And it will ask you the end snap ID. As usual, we can always generate a bigger AWR report by selecting a different snap ID, but as a thumb rule, try to generate AWR report between the 1 hour interval. So hit enter, and this script will ask you to give a name to your AWR report. The default name, it's saying like it will create a report saying like this. It creates a default name for your report. You can just hit enter and it will automatically generate the AWR report in the location where you started your SQL plus. All right. So I'm just hitting enter. I'm not giving any value. Now you can see using the report name AWR underscore one underscore, it is putting the snap ID names 1063 and snap ID numbers. And now it is generating the AWR report. You don't have to worry because it's an HTML report and you won't be able to read it on the screen. How you can read it? You can only read it if you open it into a web browser. So if I exit from SQL plus ls-lrt, this is the AWR report. All right. And this AWR report you need to open in Firefox or Google Chrome, depends on which one. So what I choose to do is I use WinSCP to copy it from this server onto Windows machine and then open it up. All right. So the thing is, guys, I can definitely copy it, but as we know, this is a test database and there is nothing in it, like technically no heavy stuff going on. So what I have done is, like in the past, because I knew we'll be looking at AWR report, what I've done is on the same database, I ran a script and which was a little heavy on the database. And I kind of like copied the AWR report from the server onto Windows machine. And this is how your AWR report will look like. Because it's an HTML document, you can double click, open it on Google Chrome or whatever browser you like. And you can see workload repository report. And guys, no, I mean, nothing hidden over here. This is just copied from the same server. So what you can do is you can use WinSCP, connect to your Linux server, and then copy the file from there back to, like how you copy, database files from Windows to Linux. And this time you're copying it from Linux to Windows. That's the only difference. And once you double click, this is how it will open. Now this snap report, if you can see, it is between snap ID 781 and 82. There was something extensively heavy running inside the database, and I wanted to show you how to read and how to find what the problem was during that period of time. And that's the reason this AWR report is very important for you. Otherwise, if you generate an AWR report for a database where nothing is going on, trust me, you won't learn anything. It will be a dummy AWR report, which makes no sense. So this AWR report, pretty important, and you can see it is on the same testdb database, the database that I connect to generally. And you can see it is between the snap interval on 6th April 11:14 to 6th April 12:09. That's the exact time between which these two snap, this snap interval, right? So guys, this AWR report, and this is how it looks like. Sometimes it might be boring and you might wonder like what exactly is all this. Of course, because as I mentioned earlier, AWR report is like dump of your entire database, what exactly was going on inside your database. So the next question is how to read it. So guys, reading AWR report in itself is a different science, but what I'll do is I'll walk you through the most important things that you should focus and few things that you should know as a DBA when it comes to AWR report. Because reading an AWR report needs at least, or learning to read a AWR report needs at least 4 or 5 sessions for me to explain you about each and every component. So I'll quickly walk you through, because as a DBA, you should know a couple of things. And in this AWR report, we will try to find out where the problem was, all right, inside the database. Okay, so we'll start with the first area. If you see, it will give your database name. What is your database ID? It's a unique ID assigned to the database by Oracle itself. And what is the unique name? That's testdb. What is the role? Primary. Let's take, if you are generating it for standby database, then definitely the role will be different. What is the edition? What is the release? If you see, this is 12c release 2. Is it a RAG database? No. Is it a CDB database? No. Container database. And that's something we are going to learn today when we jump into the multi-tenant architecture. and the host name where your database is hosted, what is the platform, number of CPUs, number of cores, number of sockets, what is the exact memory on the server. You can see like this server where this database is hosted, the available memory is 3.64 GB. Technically it's 4 GB server, so definitely the 0.4 GB memory is going for the operating system, and the rest of the memory is available for other applications. Now this will give you the details of the snap between like what is the end and what is the start and end snap IDs between which this report has been generated. And you can see what are the total number of sessions that were during the start of the snap and during the end of the snap. Now, you might see a couple of data like ADDM findings on the average active session, but will directly jump onto the load profile. This is the most area where you need to look at when understanding how your database stands between those snap intervals. This is I can't tell you the importance of this one, because of the load profile you can actually define uh, maybe 50% of the problem inside the database. It's only 50%. Okay, there are other areas in this report where you will understand how to find the problem. So in the load profile, it actually provides the snapshot of the database workload that occurred between those snap intervals. Like what was the load inside the database during that interval. Now, if you start with DB time, right? So what exactly is the DB time? DB time is the time Oracle spent performing database user calls. So what is the amount of time that was spent inside the Oracle database for Oracle to work on user calls? And as I mentioned earlier, guys, this is a test database. You won't get right data, and this is just simply the dummy data. And then but of course, when you are working on a production system, these are important things to look at. But guys, this load profile will give you a sense how the entire server is functioning, like your CPU, your database, and your instance. So it will give you a general idea about what is the load on your database or where exactly might be the problem. Okay, we start identifying it in some time. Next is database CPU. This is again an important area where you understand amount of CPU time spent on user calls. Like the server, what is the time that server spent in order to execute the user queries? Again, this is some dummy data. I think I won't conclude it, not really the right data that we have. So because this is a test database without any load, I would definitely ignore these two because it is technically wrong. Next would be like the redo size. Now, if you see, like looking at the load profile, we can directly say that, oh my God, there was a huge redo generation between these two snap IDs. All right, because we can see it, right? Simply so many bytes of redo has been generated. So now we are trying to understand a little bit, okay, that means something was going on inside the database during that time, and a lot of redo was generated, and we can see that. All right, and we can see that 14 KB of redo is being generated by every transaction. This is per transaction, right? And per second, 509 MB, sorry, KB of redo is being generated per second. So this becomes a challenge. This is where we found our first problem. Okay, so we'll come back to this redo size and all in some time. Let us look at other important parameters in the load profile. So the next one would be the physical reads. This is again pretty important. Now, this will tell us like the number of blocks requested causing the IO operation. Like, because physical reads will define the number of IO. And again, guys, in this situation, we can see physical reads is pretty less, but if we see physical writes, it is more. That means, was there some kind of insert kind of thing was happening inside the database? Might be. We can see read is less than write, correct? Or we can say that writes are more than reads. That means this redo generation might have been because of the insertions or updates inside the database. These are just estimates. We are trying to make some hypothesis out of these numbers. And next would be the user calls. Do we see user calls in this one? Yeah. This user calls is again an important parameter. This will define the number of user queries that were generated within those snap interval. Again, as per the dummy data, we can conclude that it is giving us wrong stats. So we are not considering this one. And guys, this all comes with experience. When you start looking through a lot of AWR reports, you understand what to ignore, when to ignore, and in which type of databases to ignore. And the last one would be, I would suggest for you, the important one would be, I think, the transactions. The rollbacks, it will show you how many rollbacks happened, but this transactions is important. It will tell you like number of transactions per second that were happening inside the database. You can see that means 34 transactions per second were going on inside the database. And as per our load profile hypothesis, we see that there were writes more than reads. That means there was some insert or update going on inside the database, and ultimately it generated huge amount of redo size. Okay, that's a simple hypothesis that we got from the load profile. So with this data, we move on to something called as instance efficiency percentages.
Please, I have questions.
Yes, Ahmed, go ahead.
What about pairs, hard pairs, and those parameters? I think it's very important to verify those parameters in profiles.
Right. Now, at this stage, what I'm talking about is the most important parameters which you must know. Of course, if we get into the data, let's take for OLTP, the parses is again important. The hard parse is important. So of course, every parameter has its own importance when it comes to type of the database. Let's take, if it is only reporting database, then what do you call, physical reads will be pretty high. If it is a data warehouse, physical writes will be pretty high. So ultimately, unfortunately, we can't go through every parameter because that will take huge amount of time. As I mentioned earlier, I'm just walking you through the most important ones which you should know. So of course, as I say, every parameter is important. It depends on the type of database, what type of OS platform, because OS is also important in some cases, and what type of transactions go inside the database. And again, one more point I just want to add, because I'm at this point, what type of performance issue is reported to you?
Please, I demand if you can organize a separate session to explain AWR report, because it
not
is
only about AWR, Ahmed. I'm telling you, performance tuning itself is a completely different training, and I do plan to take one, but unfortunately, because this is a requested topic and you all should know some important areas in AWR, I'm just walking you through. What I'm doing at this stage is, this was a problem reported to me by I'm assuming somebody reported to me, Arun, this is the AWR report, and find the issue. So I'm trying to help you guys understand how I am reaching to the problem. But
okay.
to read a complete AWR report is a complete different zone, guys. So I'm really sorry. I know the experienced DBAs want to learn in detail, but unfortunately that is not possible. That is out of scope actually. So what I'm trying to come to a hypothesis or a scenario is there was a high redo, high physical writes, and I can see 34 transactions per second going on inside the database. That means there is something to do with insert or updates. All right, so I'm preparing my hypothesis. As I mentioned, Ahmed, like every parameter is important, but at this stage that's not the goal. Our goal is to identify what was the problem inside the database during this snap interval, and I'm helping you guys to identify the problem. All right. Now, the next area that I would definitely look at is instance efficiency percentages. Now, as it says, the target is 100%. Trust me, the goal of all these instance percentages should be nearing the 100%. So like in our case, all are above 90% or close to 100. That means there is no problem in the database instance. All right, you don't need to tune the database instance except for this one. Now you might say like, okay, Arun, you said everything should be 100%. This one is below 100%. Then what does it mean? Except for this parameter, guys, parse CPU to parse elapsed percentage. I mean, I think that's how we call it. So this actually shows how much time the CPU is spending parsing the SQL statements inside the database. I would repeat it for you guys. This will actually show how much time the CPU is spending in parsing the SQL statement. Now, only for this metric, like only for this one, the lower this matrix, the better. Okay, so don't try to think that okay, it is low, that means there is a problem. No, only for this parameter, this is the exception. And for this parameter, as low as it can go, then it is better. You must tend to look into or investigate why CPU is being spending so much time only if this percentage goes above 10%. And like looking at these parameters, I can quickly say that, okay, the instance is perfectly fine. So no instance tuning is required. A lot of you guys ask me this question, I don't know, within this training or maybe on email, like when to start instance tuning, or how do you decide to increase the memory or the size of your instance. This is one area. And I think, wait, where is the other area? Yeah, can you see shade pool statistics? This is again important, but I think that's the one. Yeah. In this one, do you see memory usage percentage? Actually, guys, in 12C, the report has been a little bit changed. So this shade pool statistics was earlier above. So if you can see memory usage percentage, this is the area, or this is the parameter that will define whether you should increase your database instance or not. So if you see, the percentage is between 78 and 80. So the healthy percentage should be between 60 and 85. That's the healthy percentage. So for example, if your percentage is 10%, that means the amount of memory you have allocated to your database instance, only 10% is being used. So it with this one, you can come to a hypothesis saying like your instance is oversized, you can reduce your instance. Okay, and let's take if your instance percentage or memory utilization percentage is somewhere around 95%. That means the amount of memory you have allocated to the database instance, 95% of it is being utilized. So that means your instance is highly utilized. So you can increase a little bit so that the percentages is below 85%. In this case, the memory usage percentage defines what is the healthy range for your instance. And depending on that healthy range, you define whether you should increase your instance or you can reduce the instance size. So coming back to instance specific percentages, the target is 100%. Do not try to overthink these percentages, because if all these percentages are above 90, guys, then that means your instance is healthy. You need not worry about it, or you need not actually start tuning the instance. I'm talking out of the experience. And I think the next important part inside this one would be this top 10 foreground events by total wait time and wait classes by total wait time. Let me talk about these first before we look at the events. All right. So guys, what happens is inside your database, the mm, how do I define? I'm thinking of a great or a different idea to explain this. Let's take okay, speed. All right, the users inside a database want answer to their queries, and that means they are looking at a speed at which they can get the answers to their problems. The thing is, of course, even Oracle wants to give the output of the query as quickly as possible in the fastest way possible. But the thing is, there might be some problems inside the database that cause the speed to reduce. Now, these problems inside the database are called as wait. Because see, if any operation is causing a wait, that is ultimately reducing the speed of the transaction, right? I think that's a smart choice of words by Oracle, because they choose wait rather than choosing something called as problems, or something called as maybe some other synonym of problems. Because every wait inside the database will impact the speed of the transaction. This is a simple equation. Now these weights might be at different level. Like let's take you have buffers, right? So what are the buffers? Buffers are the blocks, or to keep it more simple, it's the memory, or data inside RAM, data in RAM. So inside anything inside RAM, we call it as buffers. Anything inside hard disk, we call it as sectors. So definitely, while reading the buffers in the memory might cause a wait, correct? And then there might be, I'm just giving you some examples, but ultimately there are a lot of wait events inside the database, okay? Now buffers, let's take your database is waiting for a lock. So some other user create or acquired a lock on records, and because of a lock on site on data, it causes a wait inside the database. There is a disk wait. Let's take a couple of transactions are reading from the hard disk. Multiple users or multiple transactions are reading from the hard disk. The hard disk cylinder needs to spin at a very high speed in order to get the data, which is stored somewhere on some sector, right? So sometimes what happens is, let's take there are 3 transactions, right? So 1, 2, 3. On the hard disk, what happens is it will first get the data for the first transaction, then it will get the data for the second transaction, then it will get the data for the third transaction. Now in this kind of case is what happens is there might be an IO wait, like your database is waiting for the disk IO to read from the disk and give the data. And sometimes might be a CPU wait, because let's take there is some OS level application that is running. It's a different application, we are not talking about Oracle database. The other application is using 95% of the CPU. So in that case, let's take you have a transaction which needs more CPU to execute, and over here 95% of the CPU is used. What Oracle will do is it will wait for the CPU to reduce, and once the CPU is reduced, then only Oracle is able to use that CPU power and then give the output to the user. So all these are very simple examples of something called as wait. Now all this wait, when you add up, that is the response time for the query. Right? Let's take over here, Oracle is waiting for 1 second, 1 second, 1 second, or for CPU 2 seconds, 2, 3, 4, 5. That means your output, we are just taking some example, you will get output in 5 seconds. Now these wait are called as wait events. Like anything that causes a wait, Oracle call it as wait events inside the Oracle database. Now, wait events is one word, and then another important word that you should know is wait classes. Now, what are these wait classes? What Oracle has done is it has divided all your wait events into classes. So, for example, you have file type wait events. All right, file type wait events. This is one event class. And then you have buffer type wait events. Buffer type wait events. And then you again have log type wait events, you have global cache wait events, you have undo related wait events. That means these are classes within which you have multiple wait events for which Oracle was waiting. So as a DBA, your job is not to know all the wait classes. Your job is not to know all the wait events. That's not the goal. And it's not possible because there is a huge list of wait events. But what you should know is when you are reading through an AWR report, you should be able to distinguish between the wait classes and wait events and try to understand where exactly the issue was. All right. So quickly, I'll first talk about the weight classes. Can you see the different types of weight classes that we have? We have like configuration weight class, we have others, we have system IO weight class, we have DB CPU, we have user IO weight class. Different weight classes are there. And if you read the wait events, okay, now can you see these are the wait events inside the database that were happening during that snapshot time? And these are the wait classes that are assigned to each wait event. The first wait event that was causing a problem inside the database was the log file switch wait event. And it was actually waiting for archiving. And there were 3 total wait events that happened. But if you see the amount of time Oracle was waiting for it to be done was 1152 seconds. This is a big problem. And guys, don't worry, this is by default reverse sorted for you by total wait time. Okay, so as we read through the AWR report, your job is to look at the top 3 or at least 5 wait events, why they occurred. And if we see in this case, 60% of the entire database performance issue was caused by this one. Or we can also say that 60% of the waiting inside the database was because of this event. Now I'm quickly attaching or building my hypothesis again up. So looking at the load profile, we can say that a lot of redo was being generated. Okay, I can see that there were a lot of physical reads, perfectly fine. I can see that there were 34 transactions per second. So that means these 3 are critical points over here. I don't see any issue with the database instance. So no changes in the database instance. And I see that log file switch wait event was creating a big problem. So with this hypothesis, what we can build is, okay, the redo were being generated, we understand, but that means Oracle was waiting for log switch. So does that mean there were a lot of log switches happening inside the database? Might be a case. So as we have built up our hypothesis, we will come back to this one in some time. But meanwhile, let me talk about a couple of more important events which you will see in your production databases, which we actually see in general. So this DB file sequential read and DB file scattered read, these two are very important. But that being said, do not jump to the conclusion. Like, of course, I'm going to give you the meaning of those wait events, but do not jump to that conclusion or implement my solution immediately. You need to build your own hypothesis, and based on matching multiple points in the AWR report, you then implement the solution that I'm going to give. So whenever there is DB file sequential read, let's take you have high weights in the DB file sequential read. We can see that 53,000 weights were there in sequential read. But again, guys, the number of weights does not define that it was a problem. I repeat, the total number of weights do not define that it was a problem. The total wait time defines what was the problem. If you see the log file switch, there were only 3 waits, but each wait was a huge time. But over here we see there were 53,820 DB file sequential read that happened, but the total time or total wait time is just 7 seconds. So that doesn't mean that it's a problem. Your problem should be based on total wait time, not the number of waits. Okay. And this is pretty important. A lot of DBAs, they get confused. They start working on this area. They start working on this one because it has high weights. They start working on this one, DB direct path right. This has more weights. No, until unless if it is a problem with the total wait time, don't try to tune it. So let's come back to DB file sequential read. What does it mean? So what Oracle is trying to do is, it is not trying to use the indexes inside your high in. Okay. What Oracle is doing is, during that period, whatever the problematic SQL was, it was not trying to use the database index or the table index that was assigned to it. So what you need to do is, you need to optimize the SQL statement or rebuild your indexes. All right. So if only if this is your highest weight event, then try to rebuild the database indexes or optimize the SQL statement. It depends what you want to do. Again, guys, as I mentioned, do not implement the solutions that I'm saying. You need to build a hypothesis. Otherwise, it might push your database to even bad performance if you just look at one parameter and start tuning the database. The DB file scattered read. The scattered read is caused because of the full table scan. Or let's take, you don't have a table where indexes, you didn't create an index, and that's causing a full table scan. If this parameter is high, then tend to create new indexes, but you do it only if it is recommended by the SQL tuning advisor that we have seen in our last session. So these wait events, they tend to give you an idea like where exactly Oracle was waiting in order like Oracle could not achieve a speedy reply or response to the user. The other important wait event that generally occurs, like I have seen personally in the production database, is free buffer waits. It technically means like you don't have the enough RAM or processes. How do I explain? All right. So free buffer waits is like you don't have enough DB writers inside your database that were able to write the buffers from your instance to the data files. I think that's the good way to put it. So if free buffer weights are frequently more inside your database, try to increase the DBWR, database writer processes, inside the database. So generally we have one DB writer process by default. So what you do is you try to add one more DB writer, increase the DB writer processes, so that this wait event will reduce the time. Again, guys, to make changes to DB writer, you need to bounce the database. So be careful. And which one is the, again, important one in this? I think log write wait time, local write wait time is like you won't see it much inside the database. And I'll talk about one parameter, log buffer space. I think that is not listed over here, but we see it frequently in the production database. If the log buffer space is a problem, then what you do is you look at increasing the log buffer size inside your database instance.
Please, for me, when I do tuning databases, when I read AWR reports, I'm concentrate essentially in top foreground event to the column percentage DB time. It is more significant that because in this report, I see that 60.2% of the DB time has consumed by log file switch, and this is a problem. And the second event, it's DB CPU. The database consume at this time 27.4 of DB time on wait for the CPU.
All right.
That is.
I think, Ahmed, we are on the same page.
Yes.
Okay. So, like as I mentioned earlier, I think I don't need to repeat. Thanks, Ahmed, for reiterating my point. We have already seen that. So what you can do is in this top 10 foreground events, always look at the top 3 and or max to max top 5. But guys, most of the times, this is out of experience I'm saying, all right? Don't try to fix all the events at one shot. Why? Because I'll tell you something. Some events are dependent on the other event. Let's take, if we tune the log file switch event, if we are working on fixing this issue, automatically DB CPU might come down. All right. So don't try to use all your tools or all your knowledge to right away tend to work on all the events, because that doesn't help you. So what happens is one event might be caused because the other event was waiting. So in those kind of cases, what you do is always try to solve the biggest problem first. Try to look at the first event and see why that event was occurring. All right. Now, that being said, coming back to our hypothesis, looking at this AWR, I can say a lot of redo being generated. There was a lot of physical writes when compared to the physical reads, and 34 transactions per second. That means something huge was going on. I see that log file switch, that means log switches were causing a lot of database wait time. You can see this is the wait time, and 60% of the total wait time inside the database was caused by this event. So with our hypothesis till now, we conclude that while the lot of redo was being generated, there was something that was causing a lot of log switches. All right. So our question or our hypothesis now is like, we need to find out what was causing those high log switches. Can we tune it? Can we change it? Or can something else be done to it? The next, I think this is like how you build the hypothesis, guys. And I'm quickly jumping into the most important area. I'm walking you to the SQL statistics, because that's where we going to identify what was causing the problem. Of course, guys, we won't have time to go through all this. And once you come to SQL statistics, the most important one you should get into is the SQL ordered by CPU time, like which SQL was causing lot of CPU to be utilized inside your database. Now, again, in this one, we quickly jump onto the first SQL. This was the one that was causing lot of issues inside the database. So what I would do is, this is the SQL text, but if you click on the SQL ID, you can quickly look at the entire SQL. Okay, and this is the one, guys, on the top of the screen. If you see, all right, what I'll do is I'll quickly generate it again for you, so it will be easy. Go to in the main report always, I mean, these I'm concluding pretty fast from this bad AWR report. I would technically go to SQL statistics. I would quickly jump to SQL ordered by CPU time. Okay, I see that this SQL is the major problem. You can see 95% of the CPU was used by this SQL. So this is a problematic SQL. I will click on the SQL ID, and this one, do you see on the top of the screen? This is the SQL. And what I'll do is, guys, I'll copy this SQL and then we will investigate this SQL. So, all right, this is the SQL, and we see that there is a loop going on. There is an insert statement that is going on, and there is a commit going on. There is an end loop and end. Can anyone tell what is the problem in this SQL statement?
Is one issue. Whenever there is a commit going on, that will write.
There's too many commits. You need to expand your transaction boundary. You can
Right.
in this case. Yeah.
Correct. So guys, what's happening at this stage is, if you see, this is a loop that has been run wantedly by me, so that I can show you how quickly you can identify the performance issues. So in this loop, what's happening is, you can see for I in 1 to, I think, 100,000, right? So these, we are trying to run the insert statement for 100,000 times, so that we can insert 100,000 records inside the table. Now, in this case, after every insert, this is a loop, guys, and don't worry, this is a PLSQL program, simple program. In this one, we are looping. So we are running this code between, okay, let me mark it, between begin and end loop. We are running this code 100,000 times inside the database. Now, while we are running, we are inserting the data into the table. Every time we can see there is a commit being done. So this commit causes, every commit will definitely force a lock switch. And because of that lock switch, the database is having lot of lock switches, and that is ultimately generating a lot of redo inside the database. Ultimately, that is causing a problem. In this case, what is the best solution, guys? What do you think? Let's take application team ran this kind of code. You got to know the problem. We see that, okay, guys, this is not done. After every record, you don't need to commit, because this is creating a problem inside the database. All other transactions are waiting, because there is a lot of wait time on the database lock switch. What is the workaround for this kind of problem? What do you think?
Either put a commit after the end loop, or use a commit after a certain number of records has been inserted.
Right. I think that's the best way. What you can do is, in these kind of cases, guys, you speak with the application team. Sometimes you can't decide. It's your job to report a problem. It's not your job to fix a problem, because this code is coming from the application team. So you give your recommendations as a DBA. You can say like, hey, rather than running a commit after every insert, why don't you insert all the records and issue a commit? This is one way. Okay. Or what you do is, you create multiple programs and you don't insert so many records at a time. Maybe you can insert, like if it is 100,000, we are trying to be generous. You say like you insert first 50,000 over here, and then you again insert the next 50,000. Of course, we need to change these numbers, but I'm not changing. I think you get the point. So what you do is you tell them like you insert in batches and then commit, or you issue the commit out of the loop. Now, again, as I mentioned, your job is to give the recommendations to the application team, not to implement things, because this will not be in your hands. Now, that being said, guys, again, this was a simple, one of the simplest examples that I personally created for you so that you understand, if I get an AWR report, this is the way I build my hypothesis. This is how I identify the performance issues. And this is how I recommend the application team to make changes to the code, or sometimes it depends. Do we need to change anything at our database end? Like if instance specific percentages, sometimes in some databases, I quickly look at the memory usage percentage and I see that it was somewhere 95%. I tend to increase the memory underscore target parameter inside the database. Ultimately, guys, this is just an overview. AWR is an ocean. Sometimes what you see is not at all a problem, and the problem you need to identify by further investigating inside the uh, AWR report. And also, guys, most of the times, many people think like, okay, whatever hypothesis you have built from the AWR report, that is enough. Not like that. Sometimes you need to wait for the next day exact. Let's take somebody saying like exactly at 11 a.m. There is a problem inside the database. So what you do is you wait for the next day, you try to generate the ASH report right exactly at the moment when the performance issue is happening. Then you combine the last day AWR report with the next day ASH report and try to build your hypothesis. Your job when you look at an AWR report is to build a hypothesis, and then you have to convince yourself that the hypothesis is correct, and then you can move with the solution. Nobody in the world, I've seen this, many experienced DBAs, they'll say, I can look at AWR and define the problem. It doesn't happen like that. Most of the times, two databases can have the same performance problem in the AWR report, but the solution might be completely different. So until unless anyone looks at a AWR report, builds a hypothesis, you should not implement the performance solution. Like one guy, what he did, as far as I remember, the DB file sequential read was causing a high weight inside the database, and I remember this was done by a junior DBA. And then what he did is he quickly went ahead and rebuilt all the indexes inside the databases. Now, my question to the junior DBA was, why did you rebuild the indexes? And his point was, somewhere online on the Google, I read if this wait event is high, then you have to rebuild the indexes. Of course, that is correct. I agree. But what's your hypothesis that led you to rebuild the indexes? Then when I interviewed that guy and I told him like, hey, listen, you have to rebuild the indexes, or I actually started debugging his database knowledge. I asked him, when do you rebuild the indexes? Or what are the situations when you need to rebuild the indexes? And then when I explained him the entire process, let's take if there is no movement of the table, or there are no huge deletes inside the table, or there is no disk fragmentation that is being done, there is no partition being moved from one location to the another location, till then you never have to rebuild the indexes. And based on that hypothesis, let's take, that's what I'm saying, don't look at any Google solution immediately for your database. That might even cause a problem inside the database. So for that database, that was not the solution. So as I mentioned, guys, sometimes just solving one event is not the issue. Sometimes, let's take, if you are considering these top three, if I'm a DBA, what I would do is I would try to solve only one event and then wait and watch, because sometimes other events are dependent on one big event. All right, guys, as I mentioned, performance tuning, definitely I would schedule a training. I'm like more interested in database performance tuning. And in case if you guys get to know, definitely join in. All the experienced DBAs I know, you want to join the performance tuning training. Guys, anyone want to share their experience of findings in the AWR report? What did you found and what solution you implemented?
Arun, before that, one question. You said that one particular SQL was taking 95% of the CPU timings. Does that mean that entire 1 hour when we analyze the report, AWR report, just for 1 hour it was taking 95% of the time?
Correct. Because that's the snap interval, right? During that interval, that was causing the problem. And that's the reason, if we go back to our diagram, I think I deleted that one. That's why we say like generate AWR report for each hour. And then you identify in that hour what happened. But guys, I think this is one secret I would share. The thing is, I'm not a fan of generating AWR report one by one until unless I look at the complete AWR. Of course, Oracle recommends you to generate every hour AWR. Like, okay, I'll come back to our example. Like 10 a.m. to 2 p.m., there was a performance issue. So as far as I'm concerned, guys, what I would do is I would actually generate a complete AWR report and then just build my hypothesis. So what I start doing is I'll build my hypothesis and then I will start generating hourly AWR reports and try to convince myself that my hypothesis is right. And once I am concrete saying like, okay, this was the problem, then I implement the solution. I mean, that's how I work. But most of the DBAs, they choose to go with hourly AWR and then they find or build their hypothesis. It depends. So yeah, guys, anyone want to share their findings of the AWR report? And
yes, me.
Sure, go ahead.
The first thing, genius DBA. If you want to use AWR reports, you have to check if you have if your client have license terms, and that you have to check if the statistics level is positioned to level 2, and diagnostic is the license terms is fixed in diagnostic. Then diagnostic and tuning packs. Then you can use AWR reports. For me, I have an experience, mini experience with tuning databases. My recent experience, AWRs don't give me any information about. I know that databases it give me information that databases suffer. But my process have I'm going to database alert log, analyze the first steps, analyze alert log databases, then trust file, then you have to generate AWR, ADDM, and ASH for the same period. And then you do, you build hypothesis, and you go to find the right solution.
All right, amazing. So now that we have got some details about this stuff, guys, I want to point you guys to some important article on my website, and that one is this one. You can actually use in real time. All right, it is known as wait. If you just type wait, and I think you need to wait for it to come up. So wait events versus wait classes. This is a good article. Try to pull up this article, and if you want, you can read through all this wait classes and what are the different wait events. But I want to point you directly to the find top weight classes inside your database. So let's take, if somebody is reporting performance issue, quickly run this query and see what weight class is causing the problem. And this query, guys, you just run and it will ask you to enter the weight class. So from the top query, the above query, if you copy the top weight class and enter the weight class name, it will give you within that weight class what weight event is causing the problem. These two queries are my handy queries when somebody immediately says, hey Aaron, the database is running slow. So I run these two queries to understand what's going on inside the database. I think this will be helpful for all the experienced DBAs.